inheriting my problem.
All right, here's the homework, right? Let's do Monday. Just end of day, whenever. I guess I can't be too loose, right? I gotta be like pretty hardcore right now. It's like, no, you bring it to my office, all right? What? No. I actually want to see the physical copies for some reason.
What time?
There's only 15 of you, so I think. Anytime during that day, just by the end of the day. All right. My office is the one with the Dutch doors next to the CE office. Okay. So you should be able to just slide in between the two doors or under my door or something if I'm not there. Okay. Hopefully I'm better. Is Ladine pretty good about grading homeworks and getting them back anytime? Okay. I'll be better than Ladine. I feel pretty confident I'll be better than Ladine. Then who?
Damon.
He's bad too.
Last semester for SEAL, he didn't get a single one back to us.
No way.
Whole semester. He just gave a final grade at the other.
Like, how does that give you any ability? Like,
He gives solutions.
but still, like, wow. Okay, well, I'm glad the bar is set low. All right. We'll see. I'm optimistic. I'm optimistic. I'll be doing very well with this. Okay. So this is due Monday. All right. What I'm asking you to do, and it's really just overall, it's an introduction to visual analysis. Right. You're gonna have to get out there and make sure you have it on your computer. You're gonna have to model something. I'm gonna get an idea of how you decide to model this. All right. What I'm looking for is we made the assumption, right, when we scaled back, right, we went from the real world to our analytical model, right, something we can model mathematically. We made a bunch of assumptions. One of those assumptions we made is that we have uniaxial stress distribution in our column, right? What's that mean? Well, we only have stress in one direction. And so I'd like you to check that assumption. And as we'll go through today, right, validating our results is probably one of the biggest steps of the entire process with modeling and with computers, right? We need to feel good about what we're putting in and what we're getting out. And so this would be something you might do when you're analyzing something, is simplifying it and just looking, say, okay, dimensionally, does this really have uniaxial stress in it? Can I assume that from the beginning? And so model in VA, right? If we're looking at whether or not this is uniaxial, you'd want to select an element, right? In VA, a model element in VA that would show you stress in the other direction, right? Perpendicular to that.
Will we do the VA for pressure?
What's that?
Will we do a visual analysis for pressure?
Do you want a visual analysis for pressure? I don't know. I kind of want to just see where you guys are going to go with it, honestly.
Is there kind of some flexibility? Like, do we want to go with the cube method where we're like doing squares that are continually smaller?
See, that's what I'm interested in, to see how you decide to model this column.
Do that, or you could do like an area or like a plate or like.
So if you think of,
thickness, like,
if you think of elements that allow us to look at stress in 2 dimensions, a plate element would be something that would allow us to look at stress in 2 dimensions, right? And so I would assume you would model it with a plate, okay? But as for how you decide to come up with the fixity at the base, that's up to you. How you're going to, is it going to be one big plate? Is it going to be 10,000 plates? How the plates are going to be configured? Are they going to be triangles? Are they going to be quadrilaterals? Are they going to be 5-sided? I mean, whatever. Okay? And so we want to look at the dimensions for the problem that we're doing by hand, right? These dimensions here. And then I want you to change the base dimension from 49 inches to 150 inches. It's almost as wide as it is tall. Yes?
What's the thickness referring to? Is that 6 inches?
Yes, that's the depth. That's how far into the page this column extends, right? Because we've got width, we've got height, top and bottom.
Oh, so it's not circular?
No.
And we are going to assume that uniform.
Uniform thickness. Uniform thickness. And I don't know, you were here the first day. Were you here the first day?
No, I wasn't.
What's your name?
Dawson.
Dawson. Welcome.
Thanks.
Welcome. Anyone else not here the first day? Jacques wasn't here the first day. All right, we're gonna do it right now. We're gonna do it. What is your little bit about yourself, okay? Where you're from, but then something interesting that obviously you've spent some time with everyone in this room, except for myself. Something that you don't think any of them know about you, okay, for each of you. And then a little bit about what is your background with the finite element analysis method, right? Did you take Ladine's class last semester? And, you know, are you working with it? Are you, like, have you worked in the field previously, and actually modeled things? How much experience do you have with visual analysis, that sort of thing?
My name is Jacques from Glasgow, Montana.
Did you say Glasgow?
Yeah.
Montana?
Yeah.
My wife's parents are from Glasgow.
No way.
Woo! Man, what a place. That's awesome.
Something interesting about me. If I was rich and smoked, I'd smoke a lot of weed.
If you were rich and smoked, you'd smoke a lot of weed?
Yep, that's a.
Wow. That is interesting. I think you just set the bar very high right now. No pun intended.
I took the dance class last semester, and that's as much as.
Experience as you've had. So you really haven't dealt with visual analysis at all then?
I did in grade 12.
Okay, so you were here
Yeah.
undergrad and now in grad school? Okay,
Yeah.
that's good to know. All right, awesome. Well, thank you, Jacques.
That's about it, yeah.
Yeah, Elias?
I'm Elias. I don't know, my mom's from Argentina, she's from the town where Messi was born, so I speak Spanish. Yeah, some people might know that, but,
Yeah, let's get, I mean, I knew that. I mean,
Yeah.
come on now. It's
It's
like,
like, do I gotta show that to everybody?
yeah, I mean, get outside the box there, like something that no one knows.
I don't know. I play the piano. I like to play the piano.
Ah, tickle the ivories, huh? Nice.
Yeah. And I took Ladine's class last semester. I've had some visual analysis experience, like kind of in Barry's class, Audrey's class. I feel like Damon has made us do some visual analysis and stuff, just like randomly, but I haven't really done any design work in the actual field of
Okay.
real engineering scope.
Real engineering scope, okay.
Yeah.
Alright, good to know. Alright, Dawson.
My name's Dawson. I'm from Fairfield, Montana.
Nice. You know Austin Batson?
Yep.
Okay.
I do.
I feel like you would, knowing
Yeah.
the size of that town.
I skipped class last week to fish.
Wow, okay. I understand motivations here.
And then.
A tournament?
Yeah, there was a tournament. Didn't win it, but. Yeah,
So it was
but
totally worth it.
It was worth it.
Yeah, yeah. What river was it on? Or lake?
It was by Augusta, Montana.
Oh, sick. Like Gibson Reservoir or like?
Oh, Willow Creek,
Oh, okay. Sweet. So like a small town derby where you do more drinking than fishing or?
maybe.
Okay.
Well, you didn't have what was the prize for the competition?
It was like, first place was like over $4,000. So
Wow.
See, so
Quick
Yeah.
buck if you win.
Yeah, totally worth it as a grad student, for
Yeah.
sure.
I did not take Ladine's class, but I've done like a little bit of VA.
Okay.
Just kind of like Elias in previous classes, just kind of randomized.
Okay. And you're not interning anywhere or anything like that you've had experience?
I interned at Morrison, Maryland, doing survey stuff the past 2 summers.
Oh,
I haven't
sick.
done like any structural work. So.
Okay. So you're playing around with Hans and
Yeah,
Matt
Hans
Nelson
and
and stuff.
Matt and
Cool.
Nick, yeah.
Sweet. All right. Welcome to you three. Where are we at? 2, 4, 6, 8, 10, 12, 14. Actually, we're only missing one.
Oh, you
Ethan. Wow. Impressive. Okay. So that's what I'm kind of expecting on the homework, and based on what you guys have given me, I think you guys can kind of work your way through it. As I mentioned, all right, in the real world, when you model something, right, and even in academia, you kind of have to give a description of how you modeled it, right? So don't just tell me one line, right? It acts as uniaxial. It's a good assumption, done deal, right? You're going to show me the model, maybe two models, right? We're going to have one with 49 inches wide, one with 150 inches. How did you decide to model it? Why did you decide to model it that way? Explain your reasoning, right? You got to defend it, okay? If this went up in court someday, you'd want to be able to defend it. Yeah, Brandon.
So since we're turning it to your office in person, are we just taking screenshots of the VA model?
Yeah, like what is the deliverable?
It'd be like a traditional given find solution homework problem set, right?
Okay, but we're just taking a screenshot